Today we are solving a good problem on partial fraction integration. We have integration of dx over x power 4 minus 5x power 2 plus 4. To integrate this, we need to decompose x power 4 minus 5x power 2 plus 4 into the simplest form. Okay, we can here substitute with x power 2 because we have here x power 2. X power 4 is equal to x power 2 power 2 minus 5 by x power 2 plus 4. So we can substitute with x power 2 equal to u. We'll have u power 2 minus 5u plus 4 equal to 0. Okay. We can calculate what can this be by calculator. I have coefficient of 1, coefficient of -5, coefficient of 4. So it is u minus 4 okay, u minus 4 multiply u minus 1. And we know that u is equal to x power 2. So x power 4 minus 5x power 2 will be equal to x power 2 minus 4 multiply x power 2 minus 1. Okay, so we will have integration of dx over x power 2 minus 4 multiply x power 2 minus 1. Now we can take 1 over x power 2 minus 4 multiply x power 2 minus 1 and equal it with ax plus b over x power 2 minus 4, the first factor, plus cx plus d over x power 2 minus 1, the second factor. And we have here a quadratic function, so I wrote ax plus b or cx plus d. Now we need to know the value of the coefficients a and b and c and d. Okay, I can multiply both sides with x power 2 minus 4 multiply x power 2 minus 1. So this will be cancelled from here, and here I will cancel this with this, so I will have ax plus b multiply x power 2 minus 1 plus cx plus d. Here these two will cancel, and we have this multiply this. Okay, will be equal to 1. We need to simplify this. We have ax multiply x power 2 will be ax power 3. Okay, plus ax multiply -1 will be equal negative ax. And we need b multiply x power 2 will be equal bx power 2 minus b. Okay, then we have cx by x power 2 will be equal cx power 3, and cx power -4 we will have -4 cx. D multiply dx power 2 will be dx power 2 minus 4d. If you see here, we don't have any of x power 3 or x power 2 or x, we only have 1. So I can take negative v minus 4d is equal to 1. This is the first equation we have. Second equation, that for the x bar 2 we don't have any x bar 2, so I can take bx bar 2 plus dx bar 2 so the coefficient of v plus the coefficient of d will be equal 0 because we don't have x bar 2 in the left hand side. And the third equation, I can take the x bar 3 coefficient, which will be equal to 0, and we have a plus c will be equal to 0, and lastly we have the x coefficient, which will be negative a minus 4c will be also equal to 0. I can write this, I can solve them with my hand, but it will be pretty long, so I will solve this by calculator. We have negative v minus 4d equal 1, and we have b plus d equal to 0, and we have a plus c equal to 0 also, and we have negative 4c equal to 0. I will have a equal x, c equal y, b equal z, d equal to t. Okay, we'll see. We have a equal to 0 and c equal to 0 and b equal to 1 over 3 and d equal to negative 1 over 3. Now we will continue to solve our problem. Okay, after getting a and b and c and d, we can actually solve the problem now. Because we have composed this. Okay, and this is the last step that we will continue. We have a equal 0, b equal 1 over 3, c equal to 0, d equal to negative 1 over 3. I substituted here with the values and make this integration into two integration. So the first one will be equal to, we have here a coefficient be outside 1 over 3 integration of 1 over x bar 2 minus 4 dx plus or minus 1 over 3 integration of 1 over x bar 2 minus 1 dx. We know that integration of 1 over x bar 2 minus 1 is equal to tan inverse. So we have here, this will be equal 1 over negative 1 over 3 tan inverse of x plus c. And to solve this, we can say that we have integration of 1 over x bar 2 minus 2 bar 2 dx. This will be equal to 1 over 2 tan inverse of x over 2. So 1 over 2 multiply 1 over 3 will be 1 over 6 tan inverse of x over 2 minus 1 over 3 tan inverse of x plus c. This will be our final answer for the integration.